Weather forecasts shape our daily choices and protect entire communities. From farmers planning crops and families deciding when to travel or play outside, to cities bracing for storms and emergency services mobilizing ahead of severe weather, accurate predictions keep us safe, help us avoid disruptions, and ensure our world keeps running smoothly. Reliable forecasts help us prepare for hurricanes, manage energy grids to prevent blackouts, and respond quickly to climate extremes like wildfires and floods, saving lives and property. Seasonal outlooks go beyond daily forecasts, predicting trends months ahead, crucial for water management, wildfire prevention, agriculture, and disaster readiness. But forecasting is tough. The atmosphere is chaotic, and even tiny changes can trigger massive, unexpected events. Traditional computer models, even with today's most powerful supercomputers, struggle to capture all the details of our complex planet and can be slow, expensive, and sometimes inaccurate when it matters most. As climate change fuels more frequent and intense weather disasters, the need for better, faster forecasts is more urgent than ever. Enter artificial intelligence, a game changer that could revolutionize how we predict and prepare for our planet's future. For decades, weather prediction relied on physics-based models, giant equations run on supercomputers using data from satellites and sensors. These early computers were massive, filling entire rooms, and required teams of scientists to operate and maintain them. The process was slow and labor-intensive, but it was the best technology available at the time. These models divided the world into large grids, often missing local events like flash floods or thunderstorms. The coarse resolution meant that smaller, fast-changing weather patterns could easily go undetected, leaving communities vulnerable to sudden storms. Processing all the data took hours, sometimes making forecasts outdated by the time they were ready. Meteorologists often had to wait anxiously for results, knowing that the weather outside could change faster than their predictions. The sheer volume of information overwhelmed traditional systems, and subtle patterns often slipped through the cracks. Important clues about upcoming weather could be buried in mountains of data, impossible to spot in time. Long-range forecasts were especially tricky, as small errors could snowball into big mistakes. Even a tiny miscalculation could lead to wildly inaccurate predictions days or weeks later, frustrating both scientists and the public. Scientists needed a faster, smarter way to handle data and spot hidden patterns, something beyond just crunching numbers. They began searching for new approaches that could keep up with the complexity and speed of the atmosphere. This search for improvement set the stage for a revolution in forecasting, opening the door to new technologies and innovative thinking that would transform how we understand and predict the weather. Artificial intelligence, or AI, learns from decades of weather data, analyzing vast amounts of information that would take humans years to process. It spots patterns that traditional models often miss, revealing insights that were previously hidden. Instead of solving equations from scratch, AI models generate detailed forecasts in minutes, not hours, making the process incredibly efficient. This speed allows meteorologists to update predictions in real time and issue faster warnings for dangerous events, potentially saving lives. AI handles massive, diverse datasets, satellite images, radar, even social media, finding the signal in the noise and making sense of it all. It zooms in for hyper-local forecasts, predicting weather for your neighborhood, not just your city, offering a level of detail never seen before. Most impressively, AI uncovers complex, non-linear relationships, like how ocean temperatures in one region can signal a heat wave elsewhere weeks later, providing early warnings. By learning directly from history, AI is pushing the boundaries of what's possible in climate prediction, offering a smarter way to see the future. AI-powered models like Google DeepMind's GraphCast now outperform traditional systems, delivering 10-day forecasts in under a minute. New tools like Aardvark Weather make advanced forecasting accessible worldwide, even for countries without supercomputers. Farmers use AI forecasts to optimize planting, irrigation, and harvests, boosting yields and conserving resources. Emergency managers get earlier, more accurate warnings for floods, wildfires, and storms, saving lives and property. The energy sector relies on AI to predict solar and wind output, stabilizing the grid and supporting clean energy. These breakthroughs are transforming how we prepare for and respond to climate risks, making our world safer and more resilient. AI in forecasting isn't perfect. Deep learning models can be black boxes, making their predictions hard to explain. Data gaps, especially in remote regions, can bias results and leave vulnerable communities at risk. Researchers are working on explainable AI and better global datasets to build trust and fairness. Despite challenges, AI is revolutionizing how we plan for weather and climate. Better forecasts help governments manage water, anticipate disasters, and support farmers. Accurate energy predictions speed our shift to renewables, fighting climate change itself. Ultimately, AI empowers us to move from reacting to weather surprises to proactively preparing for the future, a crucial step toward a safer, more sustainable world.